Welcome back, students, to the online lecture after quite a long time. This is actually because we have limited time during the offline sessions. So some of the sessions we will be solving in online mode. That is, the concepts will be taught in the offline classes, and some of the numericals on the continuation of some of the concepts will be taught in the online session. That is recorded session. Okay. Myself Asif, and first of all I would like to thank my friend Professor Karthik of Department of Civil Engineering for providing me these presentations. So now we will continue with the offline class. We have done the centroidal calculation for rectangular section. Now we will continue with the triangular section. So we have a triangular section like this. That is, it is having a height h. It is having a height h and having width b. This is the x-axis and this is the y-axis. This is a right angle triangle like this. So in order to calculate this, in order to calculate the y bar, what I do is I will consider a section. I will consider a section d having width dy at a distance of y from the y-axis. So I can write, consider an elemental strip of thickness dy at a distance y from the x-axis, such that this elemental area, this dA elemental area, I can take it as what? I can write it as b1 into dy. Now by similarity of triangles, you can write, you can see here by similarity of triangles, and considering this triangle as a whole, then this is b and h, and this small triangle, if I am writing, this one is having b1, and this distance is what? H minus y. This distance is h minus y. Then I can write b1 by b is equal to h minus y divided by h. From here I'll get b1, and substituting this in dA I can write in terms of b1 as b by h into h minus y dy. And you know, y bar, that is the central distance of this y bar, is equal to integral y dA divided by integral dA. Substituting this value for dA from here, substituting back this one, you will get y bar is equal to, this strip has to travel along from, this strip has to travel along from here, it has to travel like from here to here to here to here to here, that is, it has to travel from 0 up to h. So the limit of the integration will be, 0 to h. Substituting back this, you will get the value for your y bar as h by 3. That is, I can say this right angle triangle, the centroid is for the distance, or the centroidal distance y bar is at a distance of h by 3 from the x-axis. Similarly, in order to find the x bar, I need to consider a section. I need to consider a section d having width dx at a distance of x from the y-axis. Here also I need to consider the similarity of triangles. In order to consider the similarity of triangles, I will be considering this section as a whole. That is, this section I will be considering as a whole, and this as another section. So writing the similarity equation, I can write h1 by h is equal to this distance. I can write it as h1 by h is equal to b minus x divided by b. In writing that, I'll get h1 is equal to this. Substituting in dA, I'll get dA is equal to h by b into b minus x dx. And you know, x bar is equal to integral dA divided by integral x dA divided by integral dA. Here the strip has to travel along a distance of, from here it has to travel like this to a distance of 0 to b. So the limit of integration here will be 0 to b, and substituting this and finding, you'll get x bar is equal to, you'll get it as b by 3, which means you have your x bar and h bar distance as y bar and x bar distance as h by 3 and b by 3, h by 3 and b by 3. That is, the centroid distance is h by 3 and b by 3. Now suppose you are given some other kind of things, like you are having the axis like this, and your rectangular figure is coming somewhat like this. So this comes your x-axis, this is your x-axis, and this is your y-axis. So as I discussed in the class, the centroid will be concentrated to the more area region. So I can say here the centroid will be concentrated to the more area region somewhere here. Say this distance is b, this distance is b, and this distance is h. Then I can say this distance is what? This is the center of gravity, and this distance is h by 3, and this distance is b by 3. Okay, now the other case that can come here is we are having the centroid like this, sorry, the axis like this. This is x, this is y, and your triangle is in this form. This is b, and the other one I can say this is h. Other one I can say this is, and using the very basic concept, I can say the centroid will be to the more area region. Here the more area region is somewhere here. So this distance is what? We know this distance is what? This distance is b by 3, and this distance is h by 3. But with reference to this axis, I can say the x bar, that is the distance from, I need to consider the x bar as the distance from the y-axis. So the distance from the y-axis, I can say the distance is what? From here to here, that is your x bar. So the x bar I can write here as x bar is equal to the total distance is from here to here, the total distance is b. So that is b minus, it will be b minus b by 3. You'll get it as 2b by 3, because the reference axis is taken at this point. We have taken the reference axis at this point, so the central distance will be 2b by 3. And here there is no change for your y bar, because the y bar, the reference axis is same. So the y bar is what? Y bar is equal to h by 3 itself. So if you know the standard thing for, if you know this standard value for your center of gravity, if you know the standard value for this center of gravity, then you could find it for any. That's the thing here. I hope you have understood this. Now we will move on to the next one. Now we will move on to the next one. That is, you are supposed to find the centroid of a quadrant of a circle. That is, you have a 1/4 of a circle. So what I do here is, I will consider an elemental area dr, which is at a distance of r from the origin or the axis origin. The total radius of this segment is r. So I can consider an elemental area dr at a distance r, which is making an angle, very small angle, d theta. So this elemental area, I could utilize this as a rectangular area, because this d theta is very small, so this curved portion is not considered. So I can write, to find x bar, consider an elemental area of thickness dr at a radial distance of r. So the elemental area dA, I can consider this as this distance. If it is r d theta, then this distance I can take it as r d theta into the thickness. That is, I can utilize this into a small rectangular strip like this, having r d theta as the length and dr as the width. So the elemental area, I can take it as dA is r d theta into dr. Also I can write the x component of this strip as x is equal to r cos theta, that is x is equal to the projection of this on x-axis is equal to r cos theta, and the projection of this on y-axis is equal to, I can write it as r sin theta. Now the basic concept of your centroid, I can write your x bar is equal to integral x dA divided by integral dA. Substituting this value for dA here, you will get dA is equal to r d theta into dr, that is x integral x I can substitute as r cos theta, x I can substitute as r cos theta, and dA I can substitute as r d theta into dr divide by integral dA. Here, as you can see, in order to do the total integration, I need to integrate from 0 to this theta has to be totally covered, that is this has to be integrated with respect to theta, as well as this has to be integrated with respect to what, the value dr also, because this radial distance r is also totally to be covered, this radial distance r is also to be covered, as well as this theta is also to be covered, that is r has to be covered from here to here. At the same time, the theta is also has to be covered from 0 to here. So this is the case of a double integration, and the limit of this is, if it is a quadrant of a circle, the limit is what, 0 to pi by 2. In this case it is a quadrant of a circle, so it is limit is 0 to pi by 2, and the r has to vary from 0 to capital R. This has to vary from 0 to capital R. So the limit of integration is 0 to pi by 2 and 0 to R. If it was a semicircle, then it would have been 0 to pi, 180 degree, that is 180 degree. Okay. So doing the double integration part, that is pure mathematical, you will get the value for x bar as x bar is equal to 4r by 3 pi. Similarly, in order to find y bar, we will substitute the value for y, that is equal to r sin theta over here, and the integration is same as the previous one. You will get the value for your y bar as 4r by 3 pi. You are supposed to by heart these two values if the derivation is not asked. So I can summarize that as the center of gravity of this object is 4r by 3 pi and 4r by 3 pi from the x and y axis respectively. So from here, if suppose you are given a semicircle like this, then the center of gravity, if I am considering the axis, this is my x-axis and this is my y-axis, then definitely the center of gravity will be somewhere here. Then I can write the x bar is equal to 0 and y bar is equal to, at a distance of, this is r is the radius of the circle, then I can write this is 4r by 3 pi, that is 4r by 3 pi. Now suppose it is given as the center of gravity is given like this. Now you are supposed to find the center of gravity of a circle like this. Then we need to consider the reference axis. It's up to you how to consider the reference axis, but based on the reference axis your CG will also change, that you have to keep in mind. So this is x-axis, this is y-axis. So I know the center of gravity is somewhere here, G is somewhere here, which is making 0 distance with the y bar. So I can write y bar is equal to 0, but x bar is equal to what, that we had derived, that is 4r by 3 pi, that is 4r by 3 pi. Now even though you can if you know this standard value of your center of gravity, that is 4r by 3 pi, whatever orientation is your semicircle provided, you could find with respect to any axis. Only you need to know the concept of where the center of gravity will be for a standard case, and that is this case. I hope you have understood these two. The remaining part we will solve in the class. Thank you.